I want to show you here how we antidifferentiate sec of x. First of all, recall that sec of x is the same as 1 over cosine of x. We could try substituting that into the integral, but actually it turns out not to help very much. The secret of doing this particular integral turns out to be a rather clever trick. Probably you wouldn't have spotted it in a month of Sundays. I'm sure I wouldn't have. What we have to do is take the sec x and multiply it by 1 in a very unusual way. Here's how it works. I've multiplied the sec by sec x plus tan x over sec x plus tan x. Of course, that combination is 1, so it hasn't changed the integral, but it has made it easier to handle, believe it or not. Let's expand out the top. Expanding the brackets, and actually I'm going to do it in the opposite order. I'm going to do the sec times the tan first. So sec x times tan x, and then the other term is sec squared of x, still divided by sec x plus tan x, and dx. Now, at first sight, that might not mean very much to you. It just seems to have made things more complicated. But look at the top and bottom. When we differentiate tan, we get sec squared. But also, and you might not remember this, when we differentiate sec x, we get sec x times tan of x. So here, the top is actually exactly the differential of the bottom. In other words, this integral has the form f primed of x over f of x dx, where f of x is the combination sec x plus tan x. When we see a structure like that, with a function on the bottom and it's exactly its derivative on the top, we know the answer. The answer simply is the log of the denominator, ln of sec x plus tan x, plus the usual constant, of course. I've put absolute value symbols around the argument in the log because we don't know whether it's positive or negative. That's the conventional thing to do. If you're not aware of that result, it's easy enough to prove simply by choosing, in general, a substitution u equals f of x. That turns the integral into the integral 1 over u du. I'll leave that as an exercise for you to check, but it's true whatever the function f. In this particular case, our f of x is sec x plus tan x, and so we get the log of sec of x plus tan x. Not surprisingly, this method can be used also to find the antiderivative of cosec x. I ought really to leave this to you as an exercise, but let me at least give you a hint. The answer is negative log cosec x plus cot x plus a constant. That at least gives you a hint as to what you ought to find on the bottom of the integral when you've multiplied by 1 in the unusual way. That concludes the presentation.